How you doing, Year 10s, and welcome to another video. This one's on precipitation reactions, which is part of our What Are the Types of Chemical Reactions series. Let's do it. Okay, Unit 3, what are the types of chemical reactions, and we look at precipitation reactions in this video. The key understandings and outcomes are you need to be able to write worded and balanced chemical equations for precipitation reactions and use the data from the solubility table to work out the precipitate and the aqueous solution. The two things that you'll be given on the exam are the list of ions and the solubility information. To work out the precipitate, you need to know what things are soluble and insoluble. Soluble means that it will dissolve in water. So if something dissolves in water, it will break into its ions, and we say that it is aqueous or it is dissolved in water. Something that is insoluble will be a solid. It won't dissolve. So that's the thing that will settle to the bottom of the test tube or the beaker, whatever you happen to do. And that is the thing that will be the solid in the precipitation reaction. So for instance, if we have a look at the solubility information, you can see that it says nitrates are soluble, which means that all nitrates will be soluble or aqueous. If we go down a bit, we can see that most hydroxides form precipitates. That means that most of the hydroxides will be insoluble, except for there are some exceptions: potassium, calcium, lithium, and ammonium. A precipitation reaction occurs when two liquids are mixed together and a solid forms, and we say that the solid bombs out of the solution. Remember that a precipitate is an insoluble ionic compound. That is, that it won't be broken apart by the water molecules. It's the solid and it sinks to the bottom of the beaker or the test tube. So for instance, chalk in water, calcium carbonate, it looks kind of milky, but if you let it settle overnight, it will form a solid at the bottom of the test tube, and I did the one with the yellow precipitate in class. So here's an example, writing a precipitation reaction. Write the equation for the following reaction. A solution of silver nitrate is added to a solution of potassium chloride. A white precipitate forms. The products of the reaction are potassium nitrate and silver chloride. So we've been given the chemical formulas, which means now we just have to put the reactants and the products in the right spot. Our two reactants, silver nitrate and potassium chloride, both solutions, both aqueous. Our products, potassium nitrate and silver chloride. Now we need to work out which one is the precipitate because they didn't tell us, so we would need to refer to our solubility information. Silver chloride is one of the exceptions. It is always insoluble. The other thing we could remember is that all nitrates are soluble, so that means that the KNO3 will be aqueous, the silver chloride will be a solid. To work out the products, the ions swap over. So the cation of silver interacts with the anion of the chloride, vice versa. I have a little way of working that out in this particular example. A solution of magnesium sulfate is added to a solution of barium nitrate, and we need to write the chemical equation. So we need to make sure that we get the formula of the reactants correct first. Magnesium sulfate is Mg2+, sulfate is SO4 2-. We can put those together to give us the formula MgSO4. Barium nitrate. Barium is Ba2+, nitrate NO3-, so I need to use brackets for the nitrate because I need two of them. To work out the formulas of the products, the ions swap over, and I can do this like a little table. So here I have my magnesium 2+ and my barium 2+. They're both cations, so they don't want really anything to do with each other. Our two anions, the sulfate and the nitrate, well, they're going to swap between the cations. So we have this crossover occurring, and then we need to get the formulas right for the products. So I have barium sulfate, BaSO4, they're both 2+ and 2-, they go together nicely. The magnesium and the nitrate though, I've still got a balance for the two nitrates. Then I refer back to my solubility table to work out which one is the insoluble product and which one is the aqueous. From the example before, all nitrates are soluble, which means barium sulfate will be the precipitate. Now I've got all the bits of the puzzle, I can put that together. My reactants on the left hand side, my goes to arrow or reacts to form. Both of them are aqueous because they're solutions. And now I can put in my products. It doesn't matter which order we put in the products, just as long as it's a balanced chemical equation and it has the correct states. I'm pretty sure that this one is balanced, so this is our balanced chemical equation for the precipitate reaction. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.